Welcome friends. Atom, the basic particle of matter. Already we made the discussion in the last session, and it is consisting of many number of particles. All the particles, those are present inside the atom, are said to be the subatomic particles. Out of subatomic particles, some of the particles are very deciding particles related to the weight, related to the chemical combination, related to the features associated with the atom, and those particles are said to be the fundamental particles. Those are three. Those are electron, proton and the neutron. We made the discussion related to the discovery of these of all fundamental particles. And neutron and proton are indicated by N and P, and these are present inside the nucleus. The electron is revolving around the nucleus in the orbits. So therefore the neutron and proton are said to be the inner nucleus particles, and electron is said to be the outer nucleus particle. Whereas here electrons are actively participated, electrons are responsible for the chemical combination of an atom with the other atoms. So now we know the total varieties of different varieties of particles. Out of that, the deciding particles by number, by name, by nature also. So therefore now atom representation should be there, whereas in the representation of atom it should hiddenly provide the complete information related to the fundamental particles. Thus atoms are represented, atom representation is already given. Now we will go for the interrelation between different varieties of atoms, because we are having many number of atoms. With respect to logical connectivity, how an atom is related to some other atoms, to make it less in number, to make it concise, how atoms are relatively connected with one another. One atom and the other atom differed from, suppose, in number of neutrons, differed in number of protons, differed completely. Then how they are known, and what is the naming related to the different varieties of atomic atoms? Where representation is clear, then it becomes very clear enough. Now we will go for the interrelation between different varieties of atoms. Yes, atomic relations. Before going to the atomic relation, the primary information related to the atoms. Every atom is associated with all varieties of fundamental particles. There is an exception, hydrogen. Hydrogen is having two varieties of fundamental particles, that is proton as well as the electron. It is not having neutron. This is the only one exceptional case which is not having any kind of neutron, and it is just satisfied with the two varieties of fundamental particles. Those are electron as well as the proton. Now different atomic relations. Some of the atoms are said to be the isotopes. Some of the atoms with respect to the others are said to be the isobars, isotones, isoelectronic species, isodiaphras, isostars and nuclear isomers also. Now let us go for the isotopes, the underlying portion that now we are going to be discussing. See, carbon is existing in nature. Yes, isotopes. See here, carbon, we are having three varieties of the availability of the carbon in the nature. Carbon 612 is there, carbon 613 is there, carbon 614 is there. Similarly, hydrogen 11 is there, hydrogen 12 is there, hydrogen 13 is there. Chlorine 1735 is there, chlorine 1737 is there. Uranium 92-235 is there. Similarly, 92-238 is also there. This set and this set, completely the carbon family one to other, are said to be isotopes to one another. Then what is the similarity? What is the logical relation present between the isotopes of atoms of elements is, here atoms of the same element, the element is carbon here, carbon here, carbon here, having different mass numbers. Same element implies same atomic number is there, same atomic number is maintained, different mass number. Here 12 is different from 13 is different from 14. Such kind of atoms are said to be isotopes to one another. So therefore carbon 612, 613, 614 all are isotopes to one another. Uranium 90-235, uranium 90-238, both are isotopes to one another. Thus here logically how they are related, atomic number is same, Z is same, but mass number is different, that is number of protons and the number of neutrons count is different. Atomic number indicates number of proton. Protons are same. Then where they are different? They are different at the number of neutrons. Thus, isotopes are having same number of protons. Atom is electrically neutral, so same number of electrons are there, but they are differed at the number of neutrons. Such kind of atoms of same element having differed at number of neutrons are said to be isotopes to one another. Second variety of atomic relation is isobars. The examples for isobars are quoted here. Carbon 614, nitrogen 714. Similarly, second example, sodium 1124 and sodium magnesium 1224. Argon 1840, potassium 1940, calcium 2040. These set are isobars to one another. This set is also isobars to one another. These three are isobars to one another. In this, one particular thing is common, that is mass number remains same, 40 versus 14, 24 versus 24, 40 versus 40. So therefore, atoms of different elements having same mass number are said to be isobars to one another. That is, elements are having difference, that is atomic number is different, but mass number Z value is same. Here in deep, if we go, here number of protons are different in isobars, number of electrons are different in isobars. Similarly, number of neutrons are also different in isobars. But what makes common, what logical relation will make them as isobars to one another is number of protons plus number of neutrons value remains same. Such kind of logically related atoms of elements of different atoms of elements are said to be isobars to one another. Next is isotones. Iso stands for same, tones stands for neutrons. That is, atoms of the elements having same number of neutrons but different at all varieties of interrelations are said to be the isotones to one another. See the examples. Silicon 1430 is there, phosphorus 1531 is there, sulfur 1632 is there. See, 30 minus 14, similarly 31 minus 15, similarly 32 minus 16, all are having same in number. Similarly, carbon 612, oxygen 816, sodium 1123, magnesium 1224. This set are isotones to one another. Second and the third sets also isotones to one another. Definition wise, atoms of different elements having different atomic and the mass numbers, but with the same number of neutrons are said to be isotones to one another. That is, atoms are different, properties are different, atomic number is different, mass number is different, but logically interrelated with same value of n. How n is calculated? N is calculated with a minus z. A minus z is equal to mass number minus atomic number is equal to number of neutrons. That number of neutrons are same. Such kind of relation containing atoms are said to be isotones to one another. Isoelectronic species, that is ions of the elements having ions of different elements having same number of electrons are said to be isoelectronic species. See, lithium plus is having 2 electrons, beryllium 2 plus is having once again 2 electrons. Similarly, boron 3 plus is also having 2 electrons. Sodium plus is having 10 electrons. Magnesium 2 plus, aluminium 3 plus are also having 10 electrons. N minus 3, nitride ion, oxide ion, fluoride ion are having 10 electrons in each. Such kind of all substances, ions are said to be isoelectronic species. That is, ions of different elements having same number of electrons are said to be isoelectronic species. Isodiaphras, that is, let us look at the examples related to the isodiaphras. Uranium 90 to 235 is converted to thorium 90 to 31 with the elimination of alpha particle. Similarly, proactinium 91 to 31 is converted to actinium 89 to 27 with the alpha elimination. This is U for uranium, TH for thorium, whereas Here Pa for proactinium, Ac for actinium. Whereas if you look at these particular relations, uranium to thorium, similarly here proactinium to actinium, such kind of compounds are said to be isodiaphers to one another. That is, atoms of different elements. Different elements stands for different atomic numbers, and also here they are associated with the different mass numbers, and they are having different number of neutrons also. Different at number of electrons, different at number of protons, different at number of neutrons. But what makes them logically interrelated? Yes, that is number of neutrons minus number of protons. That value remains same and constant in the atoms of different elements. Such kind of compounds are said to be isodiaphers to one another. That is, atoms of different elements having different at mass number, atomic number and neutron number, but having logically interrelation with the same quantity of A minus 2Z. A stands for number of neutrons and the proton, Z stands for number of protons, that is n plus p minus 2p, that is n minus p value is same. N minus p of first one and n minus p of second one is same. Similarly, n minus p of first one and n minus p of second one is same. Such kind of compounds are said to be isodiaphers to one another. That is, different at elements, different at atomic number. Different at atomic number stands for different at number of protons, different at number of electrons, different at number of neutrons also, but logically interrelated in such a way that A minus 2Z, that is n minus p value of elements, if it is same, then those of all are said to be isodiaphers to one another. Isostars, that is molecules like carbon dioxide and the nitrous oxide L2. If you look at the atomicity, total number of atoms are 3 in both the cases, that is same, and total number of electrons, carbon is having 6, oxygen is having 8, total is of 22 here, 22 here. That is, molecules having same atomicity and the same number of electrons are said to be isostars to one another. Are said to be isostars to one another. That is, molecules having same number of atoms, that is same atomicity, and same number of electrons, electron count is also same, are known as isostars to one another. Last variety of the atomic relations is nuclear isomers, that is atoms of the same element having same atomic number, same mass number, same number of neutrons. All relations are logically valid with respect to electrons, to protons, to neutrons, to atomic number, mass number, chemical properties, physical properties, etc. But they are different at the nuclear energy. So therefore, one is having lower nuclear energy, other is having higher nuclear energy. One may be non-radioactive, other may be radioactive. Else, both may be radioactive with differs at the radioactivity. So therefore, such kind of substances are said to be nuclear isomers. That is, atoms of the same element having different at nuclear energy levels are said to be nuclear isomers to one another. Technetium 4399, one is non-radioactive, other one is radioactive. Cobalt 60, one is non-radioactive, second one is radioactive. Such kind of substances are said to be nuclear isomers to one another. Average atomic weight. In case of certain elements, what happens is more than one isotopes are available in the nature. But while calculating the molecules weight formed by the corresponding atoms of the elements, different weights will give a lot of confusion. So therefore, on behalf of their average availability, a average weight is given for the atoms of the element. Thus, we will be getting fractional weights also. Suppose in case of chlorine, we will be having the atomic weight of chlorine as 35.5, though whole number of neutrons it is having, whole number of protons it is having, because chlorine is available in two varieties of forms in nature, majorly chlorine of 1735 with 75 percentage, chlorine of 1737 with 25 percentage. So roughly if I collect 4 atoms from nature of chlorine, out of those 4 atoms, 3 are of chlorine 1735 and 1 is of chlorine 1737. So therefore, on behalf of its average availability, its percentage of availability, average weight was proposed for the chlorine as its corresponding atomic weight to avoid the difference, to avoid the gap present in the exact weight as well as the practical weight. Thus, average weight of chlorine can be given by 75 percentage of 35 weight and 25 percentage of 37 weight, that will becomes equal to 35.5. Thus, chlorine is considered to be chlorine 1735.5. It gives the exact information of weights related to the chlorine, though you may collect chlorine from any source. Similarly, copper 29 atomic weight is having 63 as 69 percentage and 65 as 31 percentage, whereas the corresponding average atomic weight on calculation, it is approximately equal to 63.5. So therefore, copper is generally known as copper 29 63.5 is the atomic weight of the copper. Like this, if more than one isotopes are present and they are having of some significant percentage of availability, so therefore in calculations related to the chemical reactions of the compounds formed by those particular elements, instead of individual isotopes weight, which gives a lot of difference, we have to take the average atomic weight. Due to having of isotopes, some of the atoms of the elements are having fractional weights, that is not due to having of non-whole number of protons and the neutrons, that is due to having of isotopes. Average atomic weight is that one. In case of isotopes containing atoms of the elements, instead of taking individual isotope, the average contribution of the isotopes weight is taken into account and corresponding weight is said to be average atomic weight of atom of an element. Rutherford model of an atom. The technical terms, technical words and the participants of the equipment or the operators are like this. Alpha rays are the nucleus of the helium. That is, helium is having 2 electrons, 2 protons and the 2 neutrons. Out of this helium, if 2 electrons are removed, then it is converted to helium nucleus. The nucleus is generally indicated with the total number of neutrons and the protons in such a way that it is consisting of 2 protons and 4 minus 2 neutrons, that is said to be the dipositively charged cationic rays are said to be the alpha particles, that is helium nucleus. Scattering, the meaning of scattering is random spreading of anything without any logic, without any intention is said to be the scattering. The next, the technical words consisting of deflection. If anything is moving in its original path, if it deviates from the original path and moves in other direction, then such kind of thing is said to be deviation. Reflection, if anything moving in its original direction comes back in its original direction, bouncing back in the original direction is said to be the reflection. Deviation of 180 degrees is said to be the reflection. ZNS, a fluorescence material, and the quantity of deviation is generally measured with respect to the deviation angle. The more deviation angle, the less deviation angle. If deviation angle is, the maximum deviation angle is 180 and such kind of deviation is said to be reflection. Similarly, here we will use gold foil, because gold is such a material, it can be made into the form of wires as well as the plates. It is malleable as well as ductile, whereas gold can be made to a thickness of 0.0004 centimeters of thickness can be made with the gold, hence gold foil is used in this experiment. And radioactive substance, that is source of alpha rays, is generally used by the Rutherford, and that is radium 88-226 is acting as radioactive substance and it liberates alpha rays. As a result, it is converted to radon. Whereas to properly project the alpha rays generated from the radioactive source, we will take the help of the lead slide, because lead is acting as absorber for all varieties of radioactive rays, whereas from a hole present in the lead plate, a small quantity of the alpha rays are exposed towards the gold foil. So therefore lead slide, which is used to observe the unwanted alpha rays, deviated alpha rays, and projects a specific directional alpha rays over the gold foil. For that purpose, we will be taking the help of lead foil, gold foil followed by the lead slide in this alpha ray scattering experiment. Alpha rays scattering experiment. and in this experiment it is consisting of a lead box in which the radioactive material radium is taken, whereas it is acting as source of alpha particles. Beam of alpha particles will come from the source of radium, whereas in the mid a glass slide made up of lead is once again kept having some hole in the mid, because all unwanted alpha rays are stopped over here and will be absorbed by the lead material. Through the hole, a small beam, some collection of alpha rays are expected to be felt over the gold foil which is adjusted to the stand. And around this gold foil, a movable glass material painted inside with the zinc sulfide fluorescence material is kept. After equipment adjusted with the proper components, alpha rays coming from the radium will be crossing through the lead plate having small hole in the form of beam. When they felt over the gold foil, the scintillations are observed in a symmetrical manner over the movable fluorescence zinc sulfide screen. Whereas here what happens is, out of many of the alpha rays coming from the small hole, almost all 99% of the alpha rays are traveling in their original direction without any deviation. They will be present at their original locations. And some percentage, almost all some 1% of alpha rays are getting deflected. Whereas in that deflections also, many are deflected with the major angle, whereas small alpha rays, small quantity of alpha rays are deflected with the minor angles. See here, this is the direction related to the alpha ray, whereas these deviations are associated with the minor angle, but here, the deviations will be very maximum. So therefore, major deflection, major angle of deflection containing alpha rays are many in number, whereas the minor angle of deflection containing alpha rays are very minimum in number. And out of 20,000 alpha rays, one ray is deflected with the maximum angle, that is at 180 degrees, that is said to be reflection. Out of 20,000, one alpha ray was observed that it is reflected in its original path, that is, it is coming bounce back in its original path. From these experimental observations, first thing is symmetrical distribution of scintillations are present, so therefore atom is having symmetrical adjustment. Second thing is, here 99% of alpha rays are travelled in their original path, implies there is no obstacle for the positive charged particles. Whereas 1% of alpha rays are getting deflected. The source of deflection, that is positive, is repelled by positive. Positive charge is concentrated at the mid of the atom. And moreover, 1% is deflected, implies the size of the positive charge is very small compared to the size of the atom. And moreover, here the deflection angles, if you look at, majority of the deflected alpha rays are having maximum angle of deflection, and some alpha rays are having minimum angle of deflection. Stands for the sphere of influence of the nucleus and the alpha rays are matching with one another. So therefore, symmetrical distribution related information once again comes from the major angles as well as the minor angle of deviations. And moreover, here one ray out of 20,000 is reflected, bounce back in its original path, implies the exact location will be very small compared to the size of the atom. That's what one ray without maximum or minimum angle of deviation with the highest angle of deflection, it came back in its original path. So from these experimental results, we conclude in such a way that might atom is in such a way that a spherical thing, a symmetrical system is there. At the center of the atom, this total positive charge is present, because alpha rays are also positively charged. Most of the alpha rays are deflected originally, so therefore most of the alpha rays are traveling in their original path, giving original scintillations at the original locations. Whereas see here, this alpha ray when come to the sphere of influence of the nucleus, deviation starts. So therefore it is deviated, it has to travel in this direction. Now it is moving with some deviation angle. Here also it is moving with some deviation angle. Symmetrical distribution is there. Wherever whichever alpha rays is more closer to the nucleus, more towards the sphere of influence, with maximum deviation, it is going to be deviated. So therefore this is minimum deviation. Whereas these are occurring with the maximum deviations. whereas one ray which is traveling exactly in the direction of the nucleus, that is deflected with the maximum angle, that is 180 degrees, that is said to be the reflection. Thus what we can feel from this experimental results is most of the space in the atom is empty. Entire positive charge is located at the center of the atom, that is known as nucleus, named by the Rutherford, and moreover the total positive charge is concentrated in the nucleus implies to make it stable, the negative charge should present at the other location, that is electron might be present at other part of the atom, because entire atom should be occupied by the subatomic particles. Moreover, here what happens is, to attain stability, electron should be present not in ideal situation, this should be in some other mode. Like these assumptions followed by the experimental observations, a model was proposed for the atom, and that model is said to be the Rutherford model of an atom. It is similar to that of the planetary model, hence it is said to be planetary model of an atom also. Let us go for the experimental inferences followed by the model related details proposed by the Rutherford for the atom. From the experimental observations, inferences can be obtained from the Rutherford model, that is 99% of the alpha rays are undeflected. The meaning is most of the space, almost all 99% of the space in the atom is empty. 1% is deflected. The reason for the deflection is same charge, that is positive charge is located at small part of the atom. Symmetrical distribution of the scintillations were observed, that is positive charge is located at the center of the atom, and maximum and minimum angles of deflection symmetry is present, also indicates that is present at the symmetrical location, that is nothing but what, at the center of the atom. And 1 in 20,000 rays were deflected with maximum angle, that is said to be reflection, implies the size of the nucleus where the positive charge is located is of very very small, that is size comparison of atom and the nucleus. If we compare, the nucleus size is very small compared to the size of the atom. Further investigations revealed from the other parts of the science, like size of atom is generally measured in terms of 10 power minus 8 centimeters order or range, whereas size of nucleus is very small, that is measured in terms of 10 power minus 12 to 10 power minus 13 centimeters order, that is size of atom is 10 power 5 times compared to that of the size of the nucleus. From these inferences, he made a model, and here another one conclusion has to be given related to the discovered fundamental particle, that is electron, which is having negative charge. So therefore, if negative and positive charges present close to one another, they destroy with one another. So therefore, Rutherford expected that negative charge is present away from the nucleus, and if it is present ideally, it undergoes attraction, thereby it can be once again leads to the cancellation, that is destruction of the atom. Hence he proposed some assumptions for the stability of the atom in such a way that electrons are expected to be revolving around the nucleus, just like how planets are revolving around the sun, and this model is said to be planetary model of an atom. Yes, Rutherford model appears to be like this, that is every atom is having most of the empty space, whereas the total positive charge is present at the center, which is known as the nucleus, named by Rutherford itself. Here the total protons, that is positive charged quantity, is present within the small space inside the atom, whereas the electrons are expected to be revolving around the nucleus to attain stability. Electrons are not present ideally, they are revolving in a perfect circular path around the nucleus, just like planets how they are revolving around the sun. Hence this model is said to be planetary model of an atom. The density of the nucleus is very very high, because the entire positive charge as well as entire mass is present inside the nucleus. The size of nucleus is very very small compared to the size of the atom. Thus the model was proposed for the atom by the Rutherford on behalf of the experimental observations, is said to be the Rutherford model of an atom, otherwise planetary model of an atom.